W is equal to W power R in pure mathematics. Sorry who are under my tutorial batch, it will be boring for you because I've discussed with you. This is for the benefit of those under Yogeshwaran. In pure mathematics, yes, we read W is equal. We read W is equal to W power R, but here it is not pure mathematics. It is automata theory or compiler theory or compiler construction theory. So we read this as W is always, we read it as string. We don't read it as W. Okay, that's what we do here, right? When we say language L is equal to, how do we read W here? We say set of strings. Strings means words. Okay, set of strings are element of A or B clanista, where this colon is read as where the string is same as reverse of the string. So I am not reading this as W is equal to W power R. Yes, in pure mathematics, it is absolutely right to say W is equal to W power R. But this is not pure mathematics that we are discussing here. Okay, what we are discussing here is applied mathematics. We apply mathematics into the context of some problem domain. Okay, here the problem domain is compiler construction or compiler theory. Theory behind how a compiler is constructed or how it works. Okay, so let me kill this because it keeps popping up. All right, so we read this as the string is same as reverse of the string. So if your string is A, B, A, then the reverse of the string is A, B, A. That is, whether you read in the forward direction or in the reverse direction, it is the same. Okay, so if your string is A, B, B, A, then the reverse of the string is you write in this direction A, B, B, A. Okay, that is nothing but a palindrome. Okay, a string that exhibits this property of whether you read in the forward direction or in the reverse direction the same is called as a palindrome, and we have discussed that in as an example problem here. It's the same question. Only difference is here it says set of string, the element of A or B clanista where the string is a palindrome. It just says string is a palindrome. In 1D, same question, but it is said in a different way. Instead of saying palindrome, it says the string is same as the reverse of the string. Same question, but how it is spelled out, how it is written is different. So answer is the same. So you have the answer in the example problem. You just copy the answer and paste it here. You have solved it. Okay. Question 2, I will come back. I am going to jump to question 3. Question 3 is a bit interesting. I am going to solve that and come back to question 2. Okay. Because question 3 is assessment 1 task, but I am going to solve it for you. So question 3 says construct a PDA for the language over A or B, where if the strings have any B's, then all A's precede all the B's. So up to here, up to here, what it means is construct a PDA for the language over A or B means over A or B means you see how I interpret, how I read this, how I understand this. The alphabet set is only A or B, only 2 alphabets. I don't read it as A comma B, A or B. And when we say construct a PDA for the language over A or B, it means the string is made up of the alphabets A or B. Okay, the string is made up of the alphabets A or B. Now the question comes, okay, I understand. The the language has only 2 alphabets. So all strings are going to be made up of these 2 alphabets A or B. Combination of A or B. But what is the pattern of string? That is very important to us. So that we can construct the machine such that the machine produces only those pattern of string. Okay. So what is the pattern? Pattern is given here. Where, if I have reason, I'm not angry. I have a reason to make this funny noise because at least you will remember for right reason or wrong reason. Okay? Where if I will ask you now, where if the strings have any B's, there should be a comma here. If the string have any B's, then all A's precede all the B's. So it means if the string has any B's means one or two B's, not the that B's, honeybee, no, this is alphabet B, one or more B's, then all the A's should precede all the B's. I know some of you will have problem with precede and succeed. Precede means to appear before. Okay, precede means to appear before. So here the language specification says, specification says, if the string has any B's, then all the A's should appear before the B's. So meaning, so I already explained earlier in class, when we say B's means one or more B's, A's means one or more A's. Okay, A's means one or more A's, B's means one or more B's. So the example strings will be, if I have a B, then all the A's must appear before the B. That's what precede means. So one B means one A. I can have many B's. Then the A should appear before. Okay? The question does not say the number of A's and B's must be equal. Does not say. So they can be unequal. As far as the A's appear before the B is fine. So here they are not equal. I can even put something like this. It's fine. It's a valid example. Okay? Don't forget I made this noise, right? If, just to wake up some of you. If the string have any B's, what happens if the string have no B's? Question is to you. I cautioned you, I will ask this. What happens if the string has no B's? Then this condition does not apply. Now you understand why I stress the if. This is exactly your rule-based system that you do in AI. If some condition satisfied, then some action. You also have nested if. If some condition satisfied, then some action, else some other action, else. You can have many nested if, then, else conditions. You also do that in programming, if I'm not mistaken. Same thing here. Okay? That's why I put a comma here. So if some condition satisfied, then the action here is all the A's must precede the B's. What happens if the condition fails? When the condition will fail? If there are no B's. If there are no B's, then the strings will be purely made up of A's. And that's what I've shown here. Purely made up of A's. Okay? This to me is an interesting problem because here there is a condition. If there are any B's, then all A's should appear before the B's. Fine. So if there are no B's, then I can have purely A's. Okay? So we are not going to do any counting here. If you observe the previous questions, there will be some sort of counting. Even the problem I solved just now, it says the number of B's are twice the number of A's. So I need to count. Okay? The number of B's are twice the number of A's. So if I have 1A, I need to have 2B. If I have 2A, I need to have 4B. I need to do counting. Okay? Here also, I is equal to J or J is equal to K. So I is equal to J means the number of A's and B's are equal. I need to count. Okay? I is equal to J means the number of A's and B's must be equal. I don't care about the number of C's. So I need to count the number of A's so that I can produce same number of B's. So I am literally counting. Okay? When J is equal to K, I need to ensure the number of B's and C's are equal. So I need to count the number of B's so that I can produce the same number of C's. Number of A's I don't care. Because I is equal to J or J is equal to K. Okay? So if you observe all the earlier questions, we'll be doing some sort of counting. Here it is A length and B length to N. This question is actually same as this question. 1A and 1C, they are similar. Okay? Here also you have 1A mean 2 times B in 1C. In 1A also, 1 time A mean 2 times B. Only difference between 1A and 1C is, in A, the A's are followed by B's. Okay, in 1C, the A's need not be followed by B's. I can have any combination. A can appear first or B can appear first. Does not matter. Okay? So, some way or other we are doing some sort of counting. Okay? So here in this question, interestingly, there is no counting. But we need to ensure something. What is that we need to ensure? We need to ensure that the machine processes the A's first. The machine processes the A's first and then processes the B, that's all. See, understanding the problem is very important. Any problem, not necessarily be theory of computation. Okay? That is one of the principal idea behind problem solving. Understand the problem first so that you can think of how to solve it. If you don't understand the problem, how good you are, you may not, I won't say you will not, you may not be able to solve it rightly. Okay? So the understanding here is, I just need to ensure the machine processes the A first, that's all. Okay? Then I am done. So I'm going to show you on the board so that I can do it very fast. So I'm going to take the smallest possible string first. So this is my start state. I can label it as Q0. And here I put my final state, label it as Q1. Okay? So A means I am going to do it here. Why, you may ask, why you are doing it here? Why can't you do it here? I am also looking ahead. I may have one A, I may have many A's. So easier to process here. So A means I am going to say, currently my stack is empty. Stack is empty. Replace it with capital A. So A means I am pushing A. That's what I am doing here. So B means I am just going to pop the A. Right? So what I'm going to do is, if I do it here, B means pop the A, it may be dangerous because I can directly go to B, but B says pop A, it won't work, right? But to be safer, what I do is, you will understand shortly. I do a lambda transition. Okay, I go here, and then what I do is, Can I process the B here itself? Okay, let us put B here itself because let's see what happens. So B means I am going to say A stroke lambda. That is, I am popping this A. So this has been processed. So how to process this? A means push A. Okay, A means push A. B means pop A. I pop the A. Stack is empty. I have two more B's, right? I've told you here, we are not going to do any counting. We only need to ensure one thing. What is that? The string, the machine should process the A's first, and only then it should process B, to ensure A's appear before the B. To ensure A's appear before the B, the machine should process the A's first. You should never process the B's first. Okay, so that the machine can only process A's first. After that, only it can process B, right? So these two B's I can simply ignore them. I say simply B means ignore because I'm not doing any counting. So B means I say ignore stack. B means I say ignore stack. Enter string has been processed. Stack is empty. Machine is the final state. Halt and accept. Okay. Let's go here. You have many A's and B's. Correct. So A means push A. Second A, you have no option. You have to process here. So A means again push A. Again A means push A. That's what the instruction says. But you have only two B's. So one B means you will pop the A. And for this B, it says ignore the stack. But your stack is not empty yet. Correct, right? Even though machine is at the final state, enter string has been processed, stack is not empty, it will become halt and reject. But it's a valid string. Okay? It's a valid string. And don't forget, I can have, as the question says, I can purely have A's. Correct, right? Because the question says, if there are any B's, then A's appear before the B's. If there are no B's, I can purely have A's. Correct, right? So what I'm going to do is, I'm looking ahead of this kind of instruction, and I am going to solve this and solve this as well. Right? So what I'm going to do is, Stack is empty. I'm going to show you how to process this now. A means I still use this. I say push A. Okay. I still say push A. For the second A, I can still say push A, no harm, because I have two B's. For the third A, I'm going to do a lambda transition. A means I'm going to say ignore the stack. So for this A, I ignore the stack. I will be here. And then B means, again it says ignore the stack. But I have two A's here, right? So what I can do? I can put one more instruction here. B means A stroke lambda. So B means I remove this A. Again, B means I remove this A. Pop A. So this is tackled. How about this one? So A means we are not doing any counting, but the A's have to be processed. So what I do is A means I use this instruction. A means I go from here to here, doing nothing, ignore the stack. A has been processed, mention as Q1, ignore the stack. But I have still three more A's, right? I do the same instruction here. So A means I say lambda stroke lambda. So A means use this instruction, ignore stack. Read A, ignore stack. Read A, ignore stack. All the A's have been processed. Stack is empty. Measure the final state, halt and accept. Okay? So what happens if you give purely a string with B's is invalid, correct, right? If you give a B, here the instruction says B means read A, write lambda. Your stack is already empty. We cannot pop an A from an empty stack. So meaning any string that you start with B is an invalid string. Even I put BA, I put simply BAA or BA. B, you give input B here. B means it says pop A. When the stack is empty, how to pop an A from an empty stack? So you cannot start a string with a B. There is no instruction to process input B at Q0. Okay? So, done. Okay? So here, we are not doing any counting. We just want to ensure the machine always processes the A first before it processes the B. Okay? So we are forcing the machine to do that. That's all. All right? 10 minutes, huh? Okay. Construct a PDA for the language over A or B where the string contains the same number of A's and B's. I'm going to show you very quickly here. Same number of A's and B's. Same number of A's and B's means I can have AB, I can have BA, I can have AB, BA. So, the number of A's and B's should be equal, that's all. The string can start with A, start with B, end with A, end with B, does not matter. Okay? There are two ways of solving this, but the thought is very simple. So A means we push A, B means we pop A. Okay? So for this question, you can solve it with a single state or you can solve it with two states. Okay? I'm just going to solve it with one state. I'm taking this string, this one. So A means I say, A means push A. I pushed A. So B means I'm going to say pop A. B means pop A. Okay? Start state as well as final state. Now I'm going to say B means push B. I'm going to say B means push B. A means pop the A. A means, sorry, not pop the A, pop the B. Pop the B. That's all. So with this machine, you can solve all valid strings that have same number of A's and B's. I'm going to show you this. A means push A. B means pop A. B means push B. A means pop the B. Done. BA. B means push the B. A means Hey. I was wondering what happened. A means pop the B. B, right? So B means push B. A means pop the B. So you may ask, so here, for example, A means I have pop B, A means I have push A. When you come to A, B, the machine cannot use this because stack is empty. It cannot pop an B from an empty stack. So it has to use this instruction. So the question that will come is, when a string starts with an A, how the machine knows, how the PDA knows it has to use the correct instruction. For this string, the machine should use this instruction for this string. But there are two instructions starting with A. How the machine knows it has to use this instruction and not this? Okay? The machine doesn't know. Okay? I have told this with my batch of tutorials. I'm afraid Yogeshwaran, whether he told you or not. PDAs are by nature, they are non-deterministic. Okay? PDAs by nature, they are non-deterministic. Non-deterministic means they cannot determine which path will lead to success. Okay? They cannot determine by themselves which path will lead to success. Okay? So, like NFA, for a PDA, there may be many paths for a valid string. Certain path will work, certain path will not work. But what theory says is, as far as there is one right path, there is at least one path that lead to success, the machine is correct. Okay? And that's what we mean by non-deterministic. Yeah. And caution, when I did this problem with one state, you can solve the same problem with two states. Okay? So when I showed you one state here, don't think of solving every PDA with one state. It is not possible. Okay? One state PDA is not possible for all questions in PDA. Okay? Don't think like that. Certain questions, yes, you can solve it with one state, which will be the start state as well as the final state. Okay? Quickly be ready with your cams. I'm going to open cams now. Sorry. Okay, while you mark your attendance, I will send the Teams invite tonight. This Saturday, we will have an online class through Teams from 11 to 1, 2 hours. Yesterday, I managed to get permission from the school to do it online because they said, it's okay, one class only replacement can be done online. Okay? Because I told you, I have to force you guys to come on a Saturday to campus. I know some of you may not be happy. So I got permission. So this Saturday I'm going to do 2 hours to replace the Thursday class that we lost a couple of weeks back. I will send you the Teams invite. I will put the link in My Times. My Times, sending you a message. This is the link you can join. The session will be recorded. In case you are not able to attend, you can still follow the recording, and the recording link will also be put into My Times so that later you can follow. Okay? But remember, Saturday's class, the replacement class online, I am going to do pumping lemma. I will explain pumping lemma so that next week when you come, you just, in tutorial class, you solve questions on pumping lemma. Okay? So if you don't attend the lecture or you don't listen to lecture, you may not be able to do your tutorials. So you have to be a bit mindful of that. The following Saturday is the convocation. So following Saturday is the convocation, so I cannot do anything. The following Saturday onwards, every Saturday until you go for exam, I will open 1 hour, 11 to 12. If you want more, I can open 2 hours. But that will be called as consultation class online. Every Saturday week after next week. I will send you the online Teams link also separately in a message. Okay? That will be consultation. If you have any questions you want to clarify, any answers you want to discuss, you can join the class. I'll be there online for that 1 hour. You can discuss. If you want more than 1 hour, I can even open it for 2 hours, maybe 11 to 1, until you go for the exams. Okay? That will be purely consultation. No attendance will be taken, and attendance is not compulsory. Thank you. Have a good evening and good weekend. Bye-bye. Yeah. Suddenly a big crowd comes. Yeah.